what we have here is a puff of smoke, a colloid. Look how it propagates as it travels. I'll go frame by frame here. Now, we're going to stop here for a second, and we're going to say, what if our observable universe, here's my arrow, what if our observable universe is right here, is here, let's say. It's really hard to see this mount. Oh, there you go. Okay, we're over here. And we don't know. Our observable universe is only this little dot here. This part is way outside. We'll never see it. So, look what happens to it as it travels through space. You see, it's got a velocity component, which we would of course be unaware of. And then look how it spreads apart. Now, if we were here, and we could only see around here, and by the way, from the inception of the solar system, that was this frame here, and here is the present. Oh, and look what happens. See, it starts to spread apart faster. It accelerates. So, what if that's all we knew? Now you can see, as any puff of smoke might do, it kind of exhibits curl-like behavior. It makes little vortices, or big vortices. And this one's got some spin to it, and its axis would have to wonder if that could be related to the so-called axis of evil, the astronomical term that seems to have been made up by George Bush Sr. Today I want to talk about Big Bang. Usually you don't like to argue multiple points because it kind of weakens each one. But you know, I'm not trying to hypothesis right now. And this is discussion, not dogma. So we're going to be throwing out a lot of ideas, and a lot of them seem absurd on the face, but none so absurd or any more absurd than the ones used to support Big Bang. So now I've shown you the puff of smoke thing, and if you throw a handful of pebbles, but somebody's riding on one of those pebbles, well, you don't expect the handful of pebbles to stay in a handful. They're going to spread out like a shotgun. And somebody on one of those pebbles would not be aware of their velocity. So, you know, we've been over this. Now, is this just entropy? In my smoke demonstration, I used a colloid, a gas colloid, smoke. And colloid is like a fog, it's a particle size. And you can have solid colloids like rock, then they have liquid colloids where the water looks muddy. And that's a particle size. It's not, you can't see straight through it. And then we have the gas colloids like cigarette smoke. At one time, I was at UCLA Library and I thought I'd find a little book on colloids. Well, I didn't. I found a whole huge section of the library on colloids. I did not start into it. And part of it was in German and part of it was in Russian. So no, I quit there. Quit while I was ahead. But I'm wondering, how about outer space? Is the universe a colloid with a particle size from 1 meter to about 10 to the 5th meters? Maybe. Anyway, I would not expect a blob of fast-moving pebbles to stay together. So that could be just entropy. And speaking of entropy, you know, my viewers now, after a little time has gone by, have become a much more sophisticated bunch. I have some subscribers so sophisticated I end up watching their videos. I'm delighted over it, really. There's a big science community on YouTube, and I want to be a part of it. You guys know about entropy, and you can identify an entropy change. And I have a previous experiment in my videos, you'll see it, breaking the second law of thermodynamics. And, you know, it's really my most important finding. Even though it was so easy to do, I didn't know it was going to be easy to do. I built a 20-foot tall thermos bottle because I thought it was going to be necessary. It turned out not to be. But anyway, please see that video because I want your critiques on it. I can't get peer review. You're my peers. Redshift is our problem. But redshift could have a couple of different causes. One of them is, of course, Doppler. That if things are moving away from each other, it doesn't bother me. Well, it kind of bothers me, but there's not much I can do about it. And it may have another explanation than space growing. However, Sabine Hossenfelder, she said she doesn't believe in conservation of energy because she thinks it's being violated if space is growing and causing the redshift. Well, I totally agree. I think that is the greatest argument I've ever heard against space growing. Because I'm clinging to conservation of energy. Why? No good reason as of right now. I mean, plenty of good reasons to cling to that one, but if it's gone, it's gone. But it's one way or the other. And here's another point which kind of justifies hers. That is, it's been pointed out before that space is not empty. And it just may be that there is some drag associated with a photon going endless distances through space. But there's no mechanism for some sort of step-down conversion of frequency. Is it going to bunch up? It doesn't make any sense at all. But if space is growing, that could be nature's way of allowing light to lose energy as it goes through space. Now that's an interesting concept, isn't it? Now, I'm not putting that out as fact. It is pre-hypothetical. But again, these are for discussion, not for acceptance. Back to Big Bang and the problems of the Big Bang. Starting with the free lunch, where you get this super big expansion that has never been observed. You know, Big Bang counts on a lot of phenomena that have never been observed. They're strictly mathematical. Math is great if you have the factors. But do we? Now, we have the background radiation. And it is supposed to be such wonderful evidence that we are exactly right about the Big Bang and the size of the universe. We have a little problem. The Webb telescope, it seems to be detecting objects so distant that actually they're outside where they thought the size of the universe was. That is one of the problems. But there's a more basic problem. The background radiation is supposed to be an echo from the Big Bang. Well, we know about photons, don't we? Photons have a little arrow, a little vector on top. A photon has direction. Now, if it's echoing, what is it echoing off of? That's not how photons act. Photons go somewhere and they're gone. They keep going forever, and an echo would presume some sort of border, some sort of edge of the universe where space is running out. Well, if you go to that spot, what happens if I stick my arm through? These are philosophical problems that are not dealt with. Now, again, back to the background radiation that was so perfect. It was so perfect when they thought, oh, 13.6 billion light years or whatever it was. Well, how about now? Now that it's much bigger, is the background radiation still just perfect? Now, I have thrown out a bunch of stuff here. I'm a steady state person. Steady state has philosophical appeal. Without going into why, let me just say that I, of course, have a proposal. I never go into these things without that. Not usually. I rarely just comment on something without some kind of solution, proposal, experiment. And my proposal this time is for a near astronomical unit telescope, a radio telescope that is made of components that we place in orbit. I don't want to say Earth orbit around the sun, because we don't actually want to put obstacles in our own orbit. That would be kind of foolhardy. And that's why I say a near astronomical unit telescope. So we place these things around the sun in solar orbit, a little lower than Earth orbit, and we link them. Now we have a big radio telescope. And I think this can be, it might not be that expensive. And it would certainly allow for very long waves. And that's what we want to see. The steady state is looking better and better, especially since it looks by the web like, not the internet, the Webb telescope, that if you go to the edge of the universe, now, let me stop this right away and define universe. To me, I have a different definition of universe than everybody else. To me, the universe is an endless Euclidean grid. And so if space is warped, it must be warped against some standard. You can't, if it was warped against nothing, it wouldn't be warped. So the universe I speak of is infinite, and I do not have a problem with the concept of infinity. When they talk about the universe, they seem to be talking about the observable universe. And observability is not a requirement to get into my universe. So, to wind it up, it looks like if you go to the edge of the observable universe and you look out every direction, you're going to see the same thing you see if you're here. Well, that argues for steady state, doesn't it? As usual, please leave those comments. At some point, I want to do a call-in show. I have the phone number for it. I'm in 702, and the number is 300 UFOs. Good phone number. Of course, when you have a number like that, you're lucky if it spells anything. And it was very difficult to find something, and that's all it would spell. If I have sufficient interest, I will set up a time, and if you're interested in that kind of thing, please leave in the comments what you think an appropriate time of the week would be. One session a week where people would call in and discuss with whoever I might be able to get as a guest. Probably nobody. I have questions that I need answered. Like, for example, when you make an electret, why does it reverse its poles during stabilization? Now that's a good one. Those famous YouTube physicists, maybe I can get some of them on here, at least by internet link, and we'll find out what they're made of.